here, we're really just continuing on with what we did in our video over the weekend. We're just looking at more of 2C.3, solving these trigonometric equations. Example 8 is another angle of depression problem, just so that we can, I think those are the trickier out of the two between depression and elevation. So we're going to practice one more of these. So a plane needs to land at O'Hare Airport. So it's currently flying at an altitude of 4,000 feet. So there's my beautiful plane. And here's the airport. I'm going to make a building. So it's currently flying at an altitude of 4,000 feet. Remember, the altitude is its height. So that's 4,000. The horizontal distance, so again, this is the horizontal between the plane and the airport, is 15,000 feet. What angle of depression does the pilot have to use to successfully land at the airport? So now I'm going to look at my angle of depression. Again, angle of depression is his line of sight to the airport, but it's coming from this horizontal one. That's the angle that I'm looking for, okay? So remember, we can create this box, and this is 15,000, and this is also 4,000. And now we're just solving. So I have my opposite side, my adjacent side, and my hypotenuse. So to solve this, I'm using the opposite and the adjacent side. So I'm solving for an angle, so tangent of theta equals O over A. So this is tangent of x equals 4,000 over 15,000. Now here, a lot of people want to start trying to put over 1 and multiply, because that's what we do for sides. So just remember that this is solving for an angle. X is here, I need to get rid of tangent. So we're going to do the inverse tangent of both sides. These cross out, I'm left with x equals, and I'm just putting the tangent of 4,000 divided by 15,000. Sorry, the inverse tangent is what that should say, of 4,000 over 15,000. And we get 14.9. Let's round that up to 15 degrees. So x equals 15 degrees. Solid. Alright, let's look at example 9. Example 9 and 10 are still trig equation problems, but they add something else to it. Okay? So you stand 40 feet from a tree. The angle of elevation from your eyes, which are 5 feet above the ground, to the top of the tree is 47 degrees. How tall is the tree? So here I am, and here you are. Here's the tree. So my angle from my eyes to the top of this tree is 47 degrees. So what that means is this angle here is 47 degrees. Now it tells us we are 5 feet tall. And I'm standing 40 feet from the tree. So how far I am from the tree is 40. So this distance is also 40. My feet to the tree and my head to the tree is the same distance. I'm not like severely leaning anywhere. So we want to know how tall is the tree. So I'm going to start by solving for this part of it. So we have our opposite side, the adjacent side, and the hypotenuse. So So x is at our opposite side, and 40 is at our adjacent side. So again, we're using tangent. So tangent of 47 degrees equals x over 40. Put it over 1 and cross multiply. We have 40 times the tangent of 47 equals x. So x equals 40 times the tangent of 47, which is 1 point. I didn't multiply by 40. Whoops. Times 40. We get 42.9. Oh, because I typed a 40 in here. Whoops. Sorry about that. Shh, just get rid of that. Okay. So x equals 42.9 feet. So that's this section right here. Okay. But that's not the total height of the tree. We don't want to forget that we only look from our eyes, and we have this part right here, which is 5. So the total height is 42.9 feet plus the 5 feet that we don't look down, right? Which equals 47.9 feet. Okay. All right, our last example we're going to look at here is number 10. From a plane flying due east at 265 meters above sea level, the angles of depression of two ships sailing due east measure 35 degrees and 25 degrees. How far apart are the ships? So let's start by drawing this. My beautiful plane drawings. And I have a ship, sailboat, and another ship with a sailboat. So it's saying that I have an angle of depression down to this ship, and I have an angle of depression down to this ship. Okay. And my plane is at a height of 265 meters. What I want to find is the distance between these two ships. So a lot going on here. So this is really kind of two problems that you have to do in one. I'm going to start with this ship. We'll call it my red ship. Okay. Again, it's going from the horizontal line all the way down to that line of sight. So my question is this 35 degree angle or 25 degree angle? Well, this is the larger angle, so it has to be the 35 degree angle. Okay, so it's going down further. I want you to look down further. So for the red angle, it'd be 35 degrees. Okay? If I draw that right triangle, all I know is that the height is 265. Now I want to find out the horizontal distance between these two ships. So I'm going to assume the horizontal distance here is going to help me. So I'm just going to put a y there, because we already have our x here. So just use a different variable. Labeling my sides, we have the opposite side, and the adjacent side, and the hypotenuse. So again, we're using our tangent. So tangent of theta is over A. So tangent of 35 degrees equals 265 over y. Cross multiply. Y times the tangent of 35 degrees equals 265. divide by the tangent of 35 degrees. Go out. I have y equals, and we're going to type this into our calculator. 265 divided by trig tangent of 35. And we get 378. We'll do 0.5 meters. That's this distance here. Now I'm going to look at my other angle, which was this one here. So this is my smaller angle. It's 25 degrees. We still know the height of that plane is 265. The height, if I just kept going along with this height, it's not going to change. Okay? And again, we found the horizontal distance here, so I'm probably going to find the horizontal distance here, which matches this distance here. I'm going to call it z, because it's another variable. So I have my opposite side, my adjacent side, and my hypotenuse. Using the opposite and the adjacent, I'm still doing tangent. Theta equals O over A. So the tangent of 25 degrees equals 265 over Z. This should be very familiar, right? It's almost the same problem again, just with a different angle. So I have Z times the tangent of 25 degrees. Equals 265. I'm going to divide by the tangent of 25 degrees. So z equals 265 divided by the tangent of 25. Is 568.3. So this whole distance here, right, is 560.3. So again, we want to solve for x, and x is just this distance right here, from here to here, just between the two ships. Well, if you look, the red plus the green is going to equal 568, so you could just write it that way, 378. Why did I put the 0.5 in the picture? Plus x is 568.3, and then I'm just subtracting. 568.3 minus 378.5. What? Oh, we get 189.8. Okay, so this is a very common setup when you're doing two different things. Okay, you have to use them to find other pieces, okay, and then add or subtract, or maybe use that piece in a new way. Okay, so these can get a little more complicated. Otherwise, that's it, and I'll see you guys tomorrow.